Next, we're going to look at this PeakMeter, the MS8236 auto-ranging digital multimeter. We're going to run through the same three quick tests: resistance, voltage, and current. Now this is a higher quality meter capable of doing many ranges as auto-ranging, so I don't have to keep rotating the knob back and forth to find the right setting. However, I do have to adjust the location of the probes whether I'm measuring current or voltage. So let's look at that. Once again, I'm going to take my probes and connect them up to the black and red leads respectively. There's black lead. There's a red lead. And here is our test 10 kilo ohm resistor from the kit. And we should just be able to go over to resistance without thinking too much about it. Notice that this is a multiple functions on one knob, so you have to make sure it comes up in ohms. In fact, it comes up in ohms. It goes right up to mega ohms because it's at an overload, which would be the same as the one on the far left-hand side for this meter. It's again an auto-ranging mode, and it's ranged all the way up there and happens to know that it starts off looking in ohms or resistance. Now there's other modes, and you get them by hitting the function key in this meter. There's a continuity mode that beeps, a diode measuring mode, and a capacitance mode, very useful, but you have to make sure in this meter there's actually a set in the resistance mode with an ohm symbol. So this is a typical multifunction meter where they sort of saved the number of knob slots by having this function changing key. All right, let's measure resistance. .85 kilo ohms. Notice it gives us the kilo ohms here on the actual meter rather than having to read it off the position on the knob. Again, that's a feature of most auto-ranging meters. Let's do voltage. Remove our resistor. Now notice we have several choices here. We have millivolts and we have volts, and of course we have DC, which is the straight line, or AC, which is the wavy line. We want to do DC volts because we know we have about a 1.5 volt battery. That's the only decision that has to be made here, millivolts versus volts. We'll choose volts. Attach our leads, and we have 1.585 volts. Just as expected. The DC is indicated in this case on the actual lower left-hand corner. A couple neat things about a meter like this is, in addition to giving you a decimal readout, it gives you this pseudo-analog dial up here at the top, which is nice if you're, say, trying to tweak up the voltage in a system. Finally, let's go and measure current. So we have to be a bit careful here. We're going to turn the meter to off, so we can turn to off on either the left or the right side. And again, current has to go through a circuit. So we're going to break our circuit. Put in a resistor. And complete the circuit through the meter, but not until we have stuck it into the milliamp setting. And this is very important. You do not want to try to measure a current on this meter without being in the proper plug, which is for measuring currents. So in currents, measuring is like a paddle wheel. Trying to measure current going through a circuit, very different than measuring voltage. In a sensitive meter like this, it requires you moving to a different plug. All right, let's go over to the microamp setting. Again, we'll be doing DC. And here you go, 159.0 microamps. Of course, that's 1.5 volts divided by 1,000 or 10,000 ohms, because it's a 10,000 or 10 kilo ohm resistor. Notice it gives you again the microamp setting right here. If we tried to move it to milliamp, we would still get a reading. 0.15 milliamps is an approximation of 159 microamps. If I go to the actual amps reading, I get nothing, and that's because a different plug, a fourth plug, is actually required on this meter to measure these very high currents. So again, that's the PeakMeter MS8236 auto ranging digital multimeter.